Chapter 15, Lesson 3. What is a circuit? Fast fact. Light up the night. The boat pictured here is ablaze with lights. The people on board can see to walk around, eat, dance, read, and find their cabins. It takes a lot of electricity to light up the night. Vocabulary preview. A circuit is a continuous path through which electric charges flow. Series circuit. A circuit in which there is only one path for the current to follow. Parallel circuit. A circuit in which there is more than one path for the current to follow. Electromagnet. A temporary magnet that is made by passing an electric current through a coil of wire that surrounds an iron core. Circuits. In the Investigate, you constructed a complete or closed circuit to light a bulb. Did you notice that for the bulb to be lighted, every connection had to be tight? A circuit is a continuous path through which charge flows. If a circuit is open in even one place, the flow of electric charge stops. You used a battery as your source of electric charge in the Investigate. Look closely at the battery. Its two ends have different shapes. One is marked plus or positive. The other is marked minus or negative. These are the terminals of the battery. Inside the battery, a chemical reaction separates charges. Electrons build up at one terminal, giving it a negative charge. The other terminal has fewer electrons, so it has a positive charge. When a wire connects the battery's negative terminal to its positive terminal, charges flow from the negative terminal and through a wire. From the wire, they flow through the light bulb, through another wire, and back to the positive terminal of the battery. The wires conduct the electric charge. So does the filament inside the bulb. This makes a continuous path along which the charge flows. In a home, school, or any other building, the source of electric current is not a battery. Trace the circuit in this picture. What happens if a wire comes loose? Like this train, current electricity needs a closed path on which to travel. It's electric current from a generating plant delivered through wires to a wall socket. Still, the idea of the circuit is the same. Light and machines work only if the circuit is complete. A switch controls a circuit. A switch in the off position opens the circuit, and charges don't move. A switch in the on position completes the circuit, and electric charge flows along the wires. Math and science. Interpret data. Electricity is measured in units called watts. A kilowatt is 1,000 watts. A kilowatt hour, kWh, is 1 kilowatt used for 1 hour. On the first day of November, this electric meter read 73,256 kilowatts. What was the reading on November 30? How many kilowatts of electricity did this business use in 1 month? This table shows the cost of electricity in 5 cities. The rate is in cents per kilowatt. How much would this business pay for November's electric bill in each of these cities? This electrician will install many switches in a home. Why? Series circuits and parallel circuits. In the Investigate, you may have discovered more than one way to build a circuit. The simplest way is to construct a series circuit in which there is only one path for the current to follow. Current can move through 1, 2, or more devices, but it must pass through one in order to get to the next. The devices in a circuit are called resistors. Resistors resist the flow of charges. The light bulbs in the circuits you built in the Investigate were resistors. So are bells, toasters, heaters, and other appliances that use electric current. The light bulbs and battery in the photograph below are connected in a series circuit. Current flows in a continuous circuit from the battery, through the first bulb, through the second bulb, and back to the battery. Both bulbs glow as long as both are in place and undamaged. If one light bulb burns out, the remaining bulb doesn't light. If any part of a series circuit fails, the entire circuit fails. Did you find a way around this problem in the Investigate? If you did, you built a parallel circuit. In a parallel circuit, devices are connected along separate paths, and current doesn't have to pass through one device to get to the next. If something stops electrons from moving along one path, they can take another. The photograph on the next page shows a parallel circuit with 2 light bulbs. The current has a closed path to travel, but there are 3 ways it can go. It can travel through both bulbs, lighting them both. If one bulb is missing or damaged, the current can travel through the other, lighting it. The flow of charges doesn't stop when one connection is loose or when one device quits. When one part of a parallel circuit fails, other parts of the circuit continue to work. Series circuit. The diagram shows a series circuit. The batteries and bulbs show how a series circuit can be wired. This gives a parallel circuit some advantages over a series circuit. For one thing, it's easier to repair. If one device stops working, it's easy to know which one needs to be replaced. The lights over the mirror in the photo are wired in parallel. When one goes out, the rest remain lighted. With a series circuit, all the devices must be tested to find a single damaged one. In addition, parallel circuits can have separate switches in them. Individual switches can turn off one device while other devices on the same circuit continue to work. Parallel circuit. The diagram shows a parallel circuit. The batteries and bulbs show how a parallel circuit is constructed. If one bulb goes out, the other bulbs stay lighted. The photograph shows a real parallel circuit. Using electric current. We use electric current in many ways. One use is in an electromagnet. An electromagnet is a temporary magnet made by passing an electric current through a coil of wire that surrounds an iron core. When the circuit is closed, the electromagnet attracts objects that contain iron, steel, or nickel. An electromagnet works because current flowing through a coil produces a magnetic field. When current runs through a coil of wire, the magnetic field is strongest inside the coil. The field causes any iron-containing object inside the core to become temporarily magnetic. Building an electromagnet is easy. All you need is a long wire, a nail, and a battery, put together as shown in the picture. The secret to making a strong electromagnet lies in wrapping the wire around the nail many times. The more loops there are in the coil, the stronger the magnetic field is. The stronger the field is, the stronger the magnet. In this case, the nail is. An electromagnet has an advantage over a permanent magnet. The electromagnet can be turned off when it's not needed. When the circuit is closed, the electromagnet is on. When the circuit is open, the electromagnet is off. Electromagnets use electric current to generate a magnetic field. These magnets can be any size. They are often used to pick up very heavy objects. You can build an electromagnet by using a battery, an iron core, and wire.